Imagine showing a robot a quick video of you assembling a part and seconds later it copies the move perfectly. Assembly Magazine says a new physical AI model can do exactly that. But what does seconds of demonstration really mean? Let's find out. Chapter 1. What the headline actually says. Assembly Magazine's article states, physical AI model learns new robot tasks from seconds of demonstration. That's the full detail we have. No numbers, no model name, no context are given in the summary. Chapter 2. From code to demonstration. The learning shift. Traditionally, teaching a robot a new task means writing lines of code or manually guiding the arm through kinesthetic teaching, a process that can take hours or days. The article hints at a different approach, showing the robot a short video instead of coding. Chapter 3. What is imitation learning? Imitation learning, also called learning from demonstrations, trains a model to map observed actions to motor commands. It's a well-studied area in AI, used in simulation and some real-world robots. The breakthrough claim is that this can work with only a few seconds of video. Chapter 4. The missing details. Seconds of what? We don't know how many seconds were used, what the demonstration looked like, or whether the robot saw the exact same objects, lighting, and tools. Without that, we can't judge how general the skill is. Chapter 5. How does this compare to kinesthetic teaching? In kinesthetic teaching, an operator physically moves the robot arm through the motion, recording joint positions. It's intuitive but slow and can be tiring. The article suggests a video demo could replace that physical contact. Chapter 6. What might be needed behind the scenes? Even if the demo is short, the model likely relies on a large pre-trained foundation model that has already seen vast amounts of robot data. The seconds may only be the fine-tuning step, not the whole training. Chapter 7. Realistic implications and open questions. If the claim holds in varied settings, it could lower the barrier for small businesses to deploy robots without expert programmers. But we still need answers. How robust is the learned skill to new objects? What happens with noisy video? How much compute is needed for inference? Until those are answered, excitement should be tempered. If you found this breakdown helpful, smash the like button, subscribe for more deep dives into emerging tech, and drop a comment. What task would you want to teach a robot in just a few seconds? Thanks for watching!